Alright, in this video we're looking at factorizing some quadratic expressions using different methods. So we'll start with a method where we take out common factor. For this method, you'll just need to look at your terms and think about what factors each term has. So for this first term, you can see there's a -3 and it's being multiplied with x. And for the second term, it's 12. So some factors of 12 are 1 and 12, 3 and 4. But you also need to notice that it is negative. So to get a -12 by multiplying two numbers, such as 3 and 4, one of them has to be a negative as well. So it could be either the 3 that's negative or 4 could be the -1. It just has to be a 1 that has to be negative. Now, if we make the 3 negative, then it will match up nicely with the -3 from the first term. You can see these two are in common. So we take this out, -3, and we put the rest in a bracket. So here we have x, and instead of having a negative sign in the middle, it's now gone because we used -3 as a factor. So all we're left with is actually just this 4 over here, and we can write this as +4. One way to check that you've factorized this correctly would be to expand it again. So if you expand this, so multiplying these two, then you can see we have -3x minus 12, which matches what we had originally. So this has been factorized correctly. All right, this next bit here, you'll realize right away the a is in common, but also you can see there's 10 in both of them as well. If you can't really recognize that, you can do a factor tree here and sort of see, well, 2 and 10 is 20. There's some other ways to make 20, like 4 and 5, so you might list them out like this. And for 30 as well, we've got 6 and 5 gives you 30. And 3 and 10 gives you 30 as well. But you always want to take out the highest common factor. You see the 5 is common, but 10 is also common, and that is higher. So we want to be choosing these two combinations and take out 10 as a common factor. And we also want to take out a as well, because they both have a's. Now, once we've done that, the rest goes in the bracket, and after taking the 10 out, you can see we're left with 2. So we write 2 here, but we're also left with 1a as well, because it had a squared to start with. So if we take a out of a squared, we still have 1a left. And the next bit here, we've got 10 taken out, so we just have 3 left, so +3. And this a has also been taken out, so we don't have anything there. So it's just this. This next example here, you will need to realize that sometimes factors can come in multiple terms. So you can see these two are both in common in these two terms. So there's this term here, this term here. But the numbers in the bracket are the same. So it's essentially same as looking at this as 2, let's say x, 2, let's say y. Let's say 2y minus ay, and you'll easily know that y is in common, and then I'll take out the y, put the rest in a bracket, and that's the factorized form. But instead of y, now you just have this term in bracket. And you can do the same method. So here we took out the y, here we take out the entire bracket, so we go x +1 in brackets. and the rest. So just like here, we put the rest inside another bracket. So we're going to put these two, the rest, in another bracket. So here we've got 2 minus a in another bracket. And that's the fully factorized form. Here we will use a different method following the idea of difference of perfect squares, or we say DOPS for this method. And the idea is that when we expand this and simplify like terms, we'll always end up with these two terms like this. So when we have a same number here, but only difference is one is plus and the other is minus, we are always going to end up with these two terms like this. So using this idea, we can this is like a shortcut of factorizing. So here, what we want a couple of terms and a negative sign in between, or minus in between, but a couple of terms that are squared. So if we go back here, we already have x squared and a minus in the middle, so it's looking good so far. However, 16 isn't squared, so we can turn 16 into something squared, and as you know, 4 squared also gives you 16. Now, because now we have put it in this format where one is squared minus another squared number, we know when we factorize this, it's going to give us this. So x plus 4, x minus 4. So this is just a shortcut of factorizing when we have difference of perfect squares. So over here, you might think, oh, we have something squared minus something squared, so we can use difference of perfect squares right away. However, we just have the a squared and the b squared, and not 4 and 9, they're not squared yet. So we need to turn them into something squared. So you know 3 is 9, 3 squared is 9, so we can put it as 3a all squared. So turning this into this, and minus in between, and as you would have guessed it, we can turn 4 into 2, so 2b all squared. And now we have a term that is all squared and another term that is all squared, minus in between, so we can turn this into 3a plus 2b, 3a minus 2b. Alright, this next bit here requires us to do an extra step, because we don't really know what squared, some number squared gives you 1200, but you can sort of see there's 12 in both of them, so we can first take out 12 as a common factor. So if we do that, so we're just taking the 12 out, then we're left with this. Now this is a little bit better, I mean this is a lot better, because we know what 100 is in terms of something squared. So it's going to be, 12 still stays there, y squared is still here, but now we're just going to turn 100 into 10 squared. And obviously the reason why is because now inside the bracket we have a something squared minus another thing squared. This means that we can use DOPS to do this. So y plus 10, y minus 10. So that's the factorized form. And this last example here, we have these two terms all squared, so that's good to go. However, this one isn't squared yet, so we'll turn this into x plus 3 all squared minus 2 squared. Now again we have something squared minus something squared, so we can just turn this into x plus 3 plus 2, x plus 3 minus 2. And our final step is to realize we have a couple of like terms inside the bracket, so we can actually do that. So 3 plus 2, and then here we have 3 minus 2, so just 1. So that's the fully factorized form. Now, this example, we're using DOPS again. So what we did here, we're doing it again, but now this time we're using surds. And surds are, just in general, you think about the surds as square roots. So over here, this example, we have x squared, which is nice. But here we don't have something squared. And nothing squared, no whole number squared is going to give you 10. Because 3 squared is 9. And then the next one up is 16. So nothing's going to give you 10. Instead, what you can do, you can turn this into, so x squared minus square root of 10 squared. And that's because if we have something square root squared, they sort of cancel each other out, and it's actually just whatever's inside there, which is 10. So we're just manipulating this number 10 and turn it into square root of 10 squared, which is same as saying 10. But in this way, we are going to get to use DOPS because we have something squared minus another thing squared. So we can turn this into x plus square root of 10 and then x minus square root of 10. This next one as well, nothing squared will give you 24. So we will turn 24 into square root of 24 all squared, and then just use DOPS from there. So x plus square root of 24, x minus square root of 24. And this last one here as well, nothing squared will give you 5. So we'll turn this into square root of 5 all squared. And then we can just do x minus 1 plus square root of 5, x minus 1 minus square root of 5. Now you might be thinking, oh well, these are just a couple of numbers and they don't have any letters attached to it, so we can just do whatever that is. But in fact, we cannot do a whole number plus or minus the number that is in a square root. So we'll leave it just as is. Alright, the very last method that we'll use to factorize quadratics in this video is by grouping. And this is useful when we have 4 terms like this. So here we have 4 terms, and from what we've learned so far, no method that we've learned so far is going to apply here, because there's just a bunch of terms here that are sort of not useful. However, what we will do instead, we are going to look at what each of these terms have in terms of their factors. So x squared is made up of x times x is x. This one's made up of a times x, this one's made up of a. So as you can see, there's a bunch of common terms here. Sorry, common factors here. So we can take out some common factors. So let's take out these two for the first two and then turn it into, so take it out and put the rest in a bracket. So we're left with x minus 1. So this is taking this out as a common factor and putting the rest, so the x here. And because there's nothing else here, we just put a 1 there, and there's a negative in between. So we've done that, and then now looking at the second half of it, we can see that a is in common, so these two a's. So we are going to take out a and then put the rest in a bracket, so x and then minus. So now a's been taken out, we just have 1 there. And these two are connected by this plus sign here. So now we have a expression that looks like this. And now what we can do from here, we have a common factor between these two terms, which is x minus 1. So we're going to take that out in front, in a bracket, and then put the rest, so these two, in another bracket, so x plus a. So we've factorized these four terms into these two factors.